So this is another tutorial to help you with the calculations related to stoichiometry. In this tutorial, I'll be going over how to calculate the amount of reactant needed for a given amount of product. The example that I'm going over is found on page 4 of your Unit 9 notes. This is one that I went over in class. It's an excellent example of one to be able to do for quizzes or tests. It says potassium chlorate decomposes with heat into potassium chloride and oxygen gas. If a manufacturer must produce 400 kilograms of potassium chloride per month to stay in business, how many grams of potassium chlorate must she decompose, assuming 100% yield? So first we need to build our chemical equation, and we're decomposing potassium chlorate. With heat, so we use a triangle there. And it is being decomposed into potassium chloride and oxygen. So first step that we have to do with this equation is, of course, balance it. So now we have a balanced chemical equation, and it's always useful to then write the numerical information that you're given by that substance. And the question that it's asking is how much potassium chlorate is needed to produce this amount of potassium chloride. So we're trying to calculate the number of grams of potassium chlorate. So we want to start with the only information we're given is the kilograms of potassium chloride. And since the question is asking us to calculate the number of grams of potassium chlorate, then we need to first change this from kilograms to grams. Since I'm trying to cancel kilograms, that's going to go in the denominator, and then that's equal to 1,000 grams. Our next step, which is just always going to be our next step, is to convert to moles. The only way we can really relate between different substances in an equation is by going through moles. That's the only relationship that we can interpret from the coefficients in an equation. So I have been given information about potassium chloride, and so I want to convert this to moles. Okay. This is the molar mass of potassium chloride. Then I need to do my mole ratio because I'm now in moles of potassium chloride, but I need to find out information about potassium chlorate. So the compound or element that's here is what goes in the denominator. And the amount of moles that we use are the coefficients in the equation. In this case, they both have a coefficient of 2. So this is the new step we've been learning, which is the mole ratio. And then now I need to convert the number of moles of potassium chlorate into grams of potassium chlorate. Then by multiplying across and dividing what's on the bottom, your answer will come out to be 6.575 times 10 to the fifth grams. And one thing you might notice when you get an answer this large is that it does seem like an awful lot of grams. And if we look back, though, to the amount of potassium chloride we were producing, we needed 400 kilograms. That's a lot. A kilogram is about the size of a shoebox. So we're needing to produce an awful lot of kilograms, and there's 1,000 grams in a kilogram, so that makes sense that our answer is very large. So this has been a tutorial to learn how to calculate the amount of product that you need to achieve a particular amount of product. I'm sorry, the amount of reactant you need to calculate a particular amount of product.